With 130 crore people, India has to overcome many challenges. Prime among them is the responsibility of the states and central government to supply regular and safe drinking water to its citizens. Potable water means it has to be non-acidic with a pH value of 7 to 8, free from organic materials or chemical contaminants like fluoride and arsenic. The other issue is of water availability. Some 718 districts of our country are facing severe water depletion, particularly of groundwater, which supplies some 85% of drinking water in rural areas and 48% of water requirements in urban areas. To bring about water security to the rural areas, the Government of India has embarked upon the Jal Jiwan Mission, under which it is working with state governments and UTs to supply drinking water in adequate quantity of prescribed quality on regular and long-term basis across the nation by 2024. This project involves building large infrastructure to source, process and supply water across India's large expanse.
In a country like ours, water is in great crisis, and water is the cornerstone of all development. The entire economic activity that you see, all that human civilization has created, everything ultimately is connected to water. So this is something that you have to solve for the country to prosper.
However, the effort required to bring clean water to all citizens of India requires a massive effort from all segments of society. Towards this end, IIT Madras, which is one of India's leaders in scientific and technological research, is working through its startup incubation centers to develop and manufacture various water technologies for harnessing water and processing clean potable water. In this episode of Science for a Self-Reliant India, we travel to IIT Madras and look at two of these incubated startups, Vayujal Technologies Private Limited, which, as the name suggests, extracts atmospheric water, and InnoDI Water Treatment Private Limited, which has developed a very innovative technology to treat groundwater which contains salts and toxins such as heavy metals and fluorides. This and much more on our special episode, Innovations in Drinking Water, only on India Science, so keep watching. India is the second most populous country in the world, with 130 crore people. It has 18% of the world's population, but only 4% of the global water resources. A report published by the Niti Aayog in June 2018, called Composite Water Management Index, mentions that India is undergoing the worst water crisis in its history, and nearly 600 million people, or 60 crores, are facing high to extreme water stress. It is estimated that by 2050, half of India's population will be living in urban areas and will face acute water problems. With rapid urbanization, it is predicted that 21 of the major cities in the country will soon have to look for measures other than natural ones to meet their daily water needs. Irregular monsoon and variations in precipitation is already impacting cities like Bengaluru and Chennai, who are faced with acute shortage.
Our population keeps increasing. The water resources are constant. So obviously there is a crisis, and because of anthropogenic activities, very many chemicals and materials are getting into water. Water is getting increasingly polluted. In a chemical sense, we say that water knows how to get itself dirty. But you need to purify this, and that costs money, energy, and many other things. So in a country like ours, water is in great crisis, and water is the cornerstone of all development. The entire economic activity that you see, all that human, civilization has created, everything ultimately is connected to water. So this is something that you have to solve for the country to prosper.
Consumption of polluted water is a major cause of ill health in India through waterborne diseases, and children are the worst affected by this, especially in rural areas and urban slums. The consumption of contaminated water is linked to the transmission of many deadly diseases such as cholera, diarrhea, dysentery, hepatitis A, and typhoid. In addition, more than 4 crore people in rural India drink water contaminated by heavy metals, fluorides, arsenic, and nitrates. According to data from the Ministry of Drinking Water and Sanitation, India has 16 states where the rural population is affected by metal-contaminated water. Of these, West Bengal, Rajasthan, Bihar, Punjab, Assam, Uttar Pradesh and Tripura have more than 10 lakh affected people. According to the World Health Organization, drinking water contaminated with heavy metal can cause serious damage to the skin, liver, eyes, and can also cause cancer. The need to ensure availability of reliable and safe drinking water supply is crucial for the health of every citizen. And given India's large and geographically diverse population, this is a logistically complex and resource-intensive exercise. The technologies to ensure clean water supply also depend on the area, number of people, and availability of resources. In the larger context, urban areas in India, like other parts of the world, have been more successful in supplying clean water through water boards and municipalities. So traditional and rudimentary techniques and solutions need to be replaced with cutting-edge technological innovations for the sourcing and supply of reliable, clean drinking water. It is also important to have a range of technological solutions catering to smaller populations. So the role of technology startups in collaboration with research and educational institutions to create products for clean water solutions is crucial.
As we have progressed, the contaminants are getting complicated. This is one aspect. But then there have been a large number of other contaminants which are probably natural in origin. They also need to be treated. The issue always is how to treat this efficiently with reduced cost. And that is a challenge that I have been saying is a materials challenge. How do you get the treatment costs lower and lower, but make the process more and more efficient? This is where nanotechnology comes in.
Chennai-based Jal Technologies Private Limited is engaged in intensive research and development of new technologies to deliver high-quality drinking water extracted out of thin air. Jal is an IIT-incubated company which has developed an affordable water extraction technology by manufacturing atmospheric water generators or AWGs. This company is the brainchild of Padma Shri awardee Professor T. Pradeep and his students Ankit Nagar and Ramesh Kumar.
The problem of water scarcity has several dimensions. First of all, one of them, for example, is depletion of groundwater, and another one is mismanagement and mishandling of current existing freshwater resources. Another issue is that several locations in India and across the globe do not have freshwater resource at all. So for such places in particular, we have identified a source of fresh water, which is humidity present in atmosphere. So there is abundant amount of water present in atmosphere, and there is more than 10 million liters of water available per person in the atmosphere. So if we tap into this particular resource, there is a possibility that there could be fresh water available for every person on the planet.
Professor T. Pradeep and his team have been working to develop nanotechnology-enabled water filters to deliver clean water at a cost of just 2 paise per litre. The team has also developed many other affordable and safe drinking water solutions using nanomaterials, from bench-scale science experiments to commercial products.
We create advanced materials, and such materials can remove, for example, arsenic from drinking water at a cost of something like 2.2 paisa per litre of clean water. It's not just arsenic-free water, every other contaminant is removed, and the water quality is as good as US EPA, Environmental Protection Agency, quality water.
The inspiration behind the AWG came from the depleting drinking water sources and the unavailability of drinking water on time. In simple terms, the atmospheric water generator is a device that collects humidity by harnessing the moisture present in the atmosphere by utilizing condensation. It works exactly the way condensation happens around a glass filled with cold water. In fact, the structural design of the AWG is inspired from a cactus plant, which has small thorn-like structures that trap air which contains moisture around the thorn to fulfill the need of water. Based on this very principle, the engineering team has developed nano-engineered micro-nano structure patterned surfaces to make the evaporators and condensers on the metallic surface trap the moisture present in the air.
So, inspired by this process, we created several such thorns, and these thorn-like structures helped us. So, you can assume a few centimeters square of a surface, it would have several thousands of thorns on it. So, we created a hierarchy of these structures on top of these thorns, and when we translated these into our machines, we found that the machines worked much more efficiently, and the energy consumption per unit liter of water produced was comparable with the global standards which are present in the market.
So let's see how this AWG works. The air enters the contraption through a section situated in front of the machine. The moisture in the filtered air gets condensed on nano-engineered cold surfaces present inside the machine. The condensed water is then collected in a stainless steel vessel. The water then goes through a 7-stage filtration system to remove all the contaminants, undesirable chemicals, and harmful gases from the water. The collected water is then passed through an ozone filter, sediment filter, carbon filter, and UV light to get pure drinking water. After the purification, minerals are added to it, namely calcium, magnesium, and sodium, after which the water becomes suitable for drinking. The AWG machine by Vayujal is indigenously designed and manufactured with an aim to alleviate the global water shortage crisis with an affordable water extraction solution that is also environmentally sustainable for the masses. Vayujal's AWG are available in 30, 100, 400, 1000 and 2000 litres per day capacities. Vayujal has already installed devices with varying capacities at IIT Madras and even a 2000 litres capacity AWG at ITC Hotel Chennai. Now that testing has been completed, the production will be scaled up for commercial use.
Based on their water requirements and the amount of water they require, we have built a range of products ranging from 30 litres per day till 2000 litres per day. And we are very happy to see the response from school kids, industrialists, and as well as people in the domestic sector. So they are very satisfied with the quality and taste of water as of now. And that is very pleasing, and we would continue to deliver this water quality and the quality of our products.
Innovative and scientific solutions like Vayujal's AWG have the potential to create water security in many parts of India by providing a means to collect water as well as purify it for human consumption.
The journey of building Vayujal started from this lab itself, where we started making tiny surfaces, few centimeter square surfaces, and we used to test them on putting them on smaller Peltier devices. we used to cool down these surfaces and collect a few milliliters of water. So that is all, where our journey started. And from translating those few centimeter squares of surfaces to a few meters square and into the machines was a 3 to 4 year period journey. And today we see that Vayujal has reached over 15 cities across the country, and we are planning to go global as well. So this journey has been phenomenal, and it's a very good example for researchers who want to see the impact of their research into the society.
Inodai Water Treatment Private Limited has developed a very innovative process to treat ground or surface water containing high dissolved salts and toxins such as fluorides, heavy metals, arsenic, nitrates and bacteria to produce clean drinkable water according to the World Health Organization standards. Traditionally, groundwater treatment is based on the reverse osmosis technology, which wastes a lot of water during treatment and uses excess electricity and chemicals. Therefore, it has a high operating cost for delivering clean drinking water, making it both expensive and difficult to use in the rural hinterland. The technology from InnoDI is called capacitive deionization or CDI, which is proving to be a good alternative to RO technology. This is a high recovery system where water wastage is just 20% against 70% from an RO system.
Yes, one of the key things that CDI delivers is in terms of water savings. When we started out, we saw that using technologies like reverse osmosis was wasting a lot of water. And that is a criminal waste, considering that water is such a scarce resource. So we wanted to build a technology that can be adapted in a way that it can save much less wastage, thereby reducing the amount of raw water that you take in. So we started by looking at various technologies. CDI came promising towards this. And we spent quite a bit of time to localize it to Indian conditions, to the water conditions that are there in India, to the power situations, to the kind of manufacturability and all this process. And that's how we spent this time towards doing this. And we have now successfully set up a manufacturing location where we can produce this in volumes and then do this.
The technology excels in terms of lower water wastage and operational cost in comparison to reverse osmosis. It does not use any chemicals, consumes low power, and has the lowest operating cost for treating water when compared to other systems available in the market. This innovative technology is used to desalinate water without using membrane filters and does not require chemicals to treat the water and uses very less power to separate salts from the water. In CDI technology, water is sent between carbon-based electrodes at low pressure and a potential difference is applied during the water flow to remove ions present in the water. These ions get absorbed to the oppositely charged electrodes, causing their removal, and the whole process does not use any chemicals.
When you send it at low pressure through a series of carbon electrodes, and then you give a very small potential difference like 1.6 volts DC and a little higher current, like 8 to 10 amperes, then you see the ions dissociate. So when you send water at low pressure, give the current and the voltage, and then water comes out. The water that comes out is totally void of minerals. Now, by altering the flow and altering the voltage, you can determine how much ions you want to retain, how much you want to let go. So this science is something that we have perfected, and this is something that makes it that you can deliver healthy drinking water where CDI can remove contaminants, but yet retain things like calcium, magnesium is good for body and able to deliver healthy drinking water to the community.
The cost of operation is very low and it takes just 10 paisa to produce a litre of purified water. Using CDI technology, the water wastage is only 20%, and unlike the reverse osmosis process, which takes away majority of the minerals from the water, the CDI technology helps in removing all toxins like fluoride, nitrite, arsenic, etc., while retaining the desired levels of minerals required for a human body like calcium, magnesium, and others. InnoDI has installed more than 150 machines across India. The aim now is to scale up production so that this technology can be used extensively to make a big social, environmental and nutritional impact on the society and help in the mission to give clean and healthy water to our citizens.
When you started the company in 2017, InnoDI was to make the products in India so that these products, these innovative products, gets applied to the Indian conditions. Indian conditions are very challenging in terms of water, in terms of the power, in terms of various other dynamics that are required. So until and unless we produce them in India for the Indian marketplace, we will not be successful. So we started off there. I am very happy to tell you that so far, almost 80% of the whole technology is now done in India. We still have another 20% to go. And that is something that we are working on to make sure in the next coming years, we make it a completely 100% made, developed and innovated in India, and which contributes not only to the Atmanirbhar mission, but also to the SDG goals that we have, UN SDG goals that we have for water.
In this episode of Science for a Self-Reliant India, we visited IIT Madras, where we saw how technology is being leveraged for pressing national causes, in this case for the elixir of life, water, a basic but life-sustaining compound. The two IIT Madras incubated companies, Vayujal Technologies, which has built a technology to extract atmospheric water and purifies it, and InnoDI, water treatment, which uses its machine to purify water with high salinity and removes impurities, are part of the larger Atmanirbhar Bharat as well as Make in India mission. It is also a symbol of how scientific research can help find solutions to pressing problems faced by our country. That's all from us in this episode of Science for a Self-Reliant India, only on India Science.